Okay, what we have here is what I would assume most people would easily recognize as either a wasp or a bee nest. These are the little compartments or cells that they lay their eggs in and have the larva developing. And in the wasps, they tend to make the structure out of a chewed up material of often a mixture of plant fibers or invertebrate prey, things like caterpillars that they might have got hold of. Whereas in bees, they actually have glands on the body which secrete wax in little plates, little scales, which they then sort of chew up and put together and form these nest structures. But what I really want to focus on is the hexagonal shape of these nest chambers and why they are hexagonal rather than square or circular or even triangular. You know, what is the reason for this? You'll find that hexagons are quite prevalent in nature. You'll find them making up the little individual facets of the compound eyes of invertebrates. You'll also find them in many geological formations, rock that is fragmented and broken up upon cooling and drying into these hexagons. There's various features around the world that are tourist attractions where people can go and see the hexagonal blocks of rock. And the reason is quite simple. It comes down to maths and shape and volume. So you'll find that circular shapes are quite prevalent in nature because a sphere in particular is the shape that is in most equilibrium with its environment. When all things are equal and everything's pushing out in an equal manner in all directions, the sphere basically gives you optimum volume for the least amount of surface area. Now, if you had to put a whole lot of circles together to make these cells, and in fact that's how these actually start out, the wasps and the bees make circular cells next to each other. But what happens is that as the material is then becoming soft or drying up and we have surface tension pulling equally in all directions, in order to try and fill the space between the individual circular blocks and therefore maximize use of that space by using the least amount of cellular material, wall material, to actually use to create the circumference of the cells, the hexagon is the shape that achieves that best, and that's mathematically proven. The angles are about 120 degrees between each of the different parts of the hexagon, and essentially they're taking up all that space that would be left between spheres that are touching each other, and they're pulling in all different directions, and they then form these straight edges, and they're essentially allowing the most use of the space, so the biggest amount of space inside the chamber for development of the larva or whatever it might be, or honey, and with the least amount of energy being expended on the creation of the cell itself in terms of the amount of building material, the bricks as it were, that are being utilized, and therefore it's a saving of energy. So nature, you'll find, you know, all over the place is not only using mathematical ratios in the creation of spirals and shapes like this. You know, think of flower petals and the ratios of limb length to hand length or fingers, for example. But it also is always trying to find the most economical solutions to complex problems. So we can learn a lot from nature.